What is hyperthreading and how does it work? I've heard the term hyperthreading thrown around a bit recently. What exactly is hyperthreading and why is it important?
Hyperthreading is where your processor pretends to have two physical processor cores, yet only has one and some extra jump. The point of hyperthreading is that many times when you are executing code in the processor, there are parts of the processor that is idle. By including an extra set of CPU registers, the processor can act like it has two cores and thus use all parts of the processor in parallel. When the two cores both need to use one component of the processor, then one core ends up waiting, of course. This is why it cannot replace dual-core and such processors.
Hyperthreading is where two threads are able to run on one single threaded core. When a thread on the core in question is stalling or in a halt state, hyperthreading enables the core to work on a second thread instead. Hyperthreading makes the OS think that the processor has doubled the number of cores, and often yields a performance improvement, but only in the region of 15 to 30% overall, though in some circumstances, there may actually be a performance hit, equals an LT, 20%. Currently, most Atom chips and all i7 and Xeon equivalent chips have hyperthreading, as did some older P4s. In the case of the Atoms, it's a desperate attempt to improve performance without increasing power consumption much. In the case of i7s, it differentiates them from the i5 range of chips. Complex processing work won't benefit much from height, but certain, simple, highly multi-threaded tasks, such as video encoding, benefit from height. In reality, there is not a lot in it.
To expand on what's already been said, hyperthreading means that a single CPU core can maintain two separate execution contexts and quickly switch between them, effectively emulating two cores at a hardware level. You get a modest speed benefit for multi-threaded workloads when compared to a normal, single core. However, it is nowhere near the benefit of having two independent cores. In terms of performance, you're best to think of it as a small boost in multi-threaded performance over a single core rather than as having performance approaching two cores. The size of the speed boost varies according to workload. Indeed, for some workloads the performance boost is quite decent. The hyperthreaded core only has one main execution unit, but certain other parts of a CPU associated with readying instructions for processing and maintaining an execution state are duplicated. Processor cores have an instruction pipeline, a queue of future instructions to be executed, that is constantly being updated, ready for the CPU to execute the instruction at the head of that queue. CPUs use these to optimize execution speed by looking at these future instructions and doing some simple, low-level pre-processing on them where possible. Such optimizations include out-of-order execution and branch prediction. Hyperthreaded cores have dual instruction pipelines, and this, along with a second set of registers, is where you get the speed benefit for multi-threaded workloads. Let's say your system is running a number of different threads at once. Your system allocates each thread to a virtual processor, and that thread will share the virtual processor with other threads, but each time the virtual processor switches between these threads, it has to basically discard that thread's whole execution context and load up another threads. But with hyperthreading, instead of your core only being able to retain one thread state at any given time, you gain the ability for that core to retain two threads execution states at once, so you can switch between those two, much less penalty, because it does not throw off the pipeline or registers, and the pipeline and registers for the other thread remains ready and hot so they can be switched and used immediately. If you are running more threads than virtual processors, you still need to do hard switching, but less often since you have a greater number of threads at a given time whose execution state is preserved.
When a single core can act as a dual core, it is hyperthreading. In detail, Intel's implementation of simultaneous multithreading is known as hyperthreading technology, or height technology. Height technology makes a single processor appear, from software's perspective, as multiple logical processors. This allows operating systems and applications to schedule multiple threads to logical processors as they would on multiprocessor systems. Hyperthreading allows a single processor to execute two threads simultaneously, but not on all conditions. Hyperthreading does not double the performance of a system, it can increase performance by better utilizing idle resources, leading to greater throughput for certain important workload types. An application running on one logical processor of a busy core can expect slightly more than half of the throughput that it obtains while running alone on a non-hyperthreaded processor. Hyperthreading performance improvements are highly application dependent, and some applications might see performance degradation with hyperthreading because many processor resources, such as the cache, are shared between logical processors. Intel hyperthreading technology makes each core can have two logical processors which share most of the core's resources, such as memory caches and functional units. Main function of hyperthreading is to increase the number of independent instructions in the pipeline. It takes advantage of superscalar architecture, in which multiple instructions operate on separate data in parallel. Intel says that hyperthreading is highly efficient because it uses resources that would otherwise be idle or underutilized. Links. Wikipedia. Stack Overflow. Multicore Programming Digital_Edition PG number 8.
If you want to support the channel, please consider subscribing.